Okay, so this video is meant for my Algebra 2 students who come from the Career Center. We have a quiz on Tuesday over sections 9.4 through 9.6. Last quiz of the grading period, last quiz of the year, and sadly the last video of the year. So hopefully you've appreciated the videos and you've watched them and you thought they've helped, and I thank you for watching them. So let's take a look at some problems that might be like the ones on your quiz. So let's start with this one. Simplify. And we have one fraction, x squared minus 5x minus 6 all over x squared minus 1. So what we need to do is we need to think of factoring, right? So we have x squared minus 5x minus 6. Two sets of parentheses. Signs are different because of that minus c, different signs. So 1 plus, 1 minus. There is no a. So we want x and x. And now I focus on the factors of 6. And those factors are 1 and 6 and 2 and 3. Now, the signs are different. So I went to subtract to get 5. Both of these get 5, but the ones that subtract are 1 and 6. Since the 1 is negative, since the 5 is negative, the 6 should be negative. The bigger number should match that middle symbol, and the 1's positive. So there is our numerator factored x plus 1, x minus 6. Okay, the bottom, x squared minus 1. I think that this is a difference of perfect squares. 1 is 1 squared. So when it breaks down, two sets of parentheses, x plus 1, x minus 1. And there is the denominator. And now, it's all about what is the same on top and bottom. X minus 1's, x plus 1's cancel top and bottom. Notice that x minus 6 does not cancel with x minus 1 because they're not exactly the same. Neither do the x's cancel because each one is linked to another number, minus 6, minus 1. So the answer is x minus 6 over x minus 1. Okay, here's our next problem. We're going to multiply these two fractions. We have 9x to the third y over 3x squared y to the third times 12x to the fourth y to the fifth over 27y squared. The first thing I would look to do is simplify top and bottom. So this 9 and 3 can be divided by 3. Divide 3 by 3, you get 1. Divide 9 by 3, you get 3. So right now I have a 3 on top, and I'm not going to write that 1. It doesn't matter. I have an x cubed on top and an x squared on bottom. The x squared goes away and makes this cubed become a first power. So that's just going to be x. You could put the first power, but you don't need to. And then we have a y on top and a y cubed on bottom. This y goes away, and it takes 1 away from that cubed. So we have a y squared on bottom. So that's the first cancellation. Now, in the second fraction, 12 and 27 share a common factor of 3. 3 goes into 12 4 times. 3 goes into 27 9 times. And that's all the simplifying for those two numbers. X to the fourth on top, no x's on bottom, so we leave it alone. Y to the fifth on top, y squared on bottom. The y squared goes away and takes away 2 from the y to the fifth to make it a y to the third. Now, we're going to look diagonally. 3 and 9. 3 and 9 share a common factor of 3. 3 goes into 3 one time. 3 goes into 9 3 times. X, nothing down here. Y squared, y cubed up there. This y squared cancels, takes 2 away from that y, makes it a 1. This 4 can cancel with nothing. This x to the fourth can cancel with nothing. So what do I have left? Well, I have an x times 4x to the fourth y all over a 3. The x and x to the fourth will combine. This is x to the fourth, that's x to the fourth, that's x to the fifth. 4 x to the fifth y all over 3. And that's an example of a problem that has no plus or minus signs. You just start canceling things. Okay, so here's our next problem, and before you write it down, let's just read it together. Simplify x squared minus x minus 12 all over 8x squared, divided by x cubed plus 3x squared all over 8x cubed minus 2x squared, divided by 4x minus 1. So a couple things to talk about first before you write it down. Number one, this is 4x minus 1 all over 1. And then we're not going to divide by these fractions. Any fraction that you're dividing by, you're going to end up multiplying by its reciprocal. So the first fraction remains the same. But then we're going to multiply by the reciprocal of the second one. And we're going to multiply by the reciprocal of the last one. And I'll keep that 4x minus 1 in parentheses. And then I'm going to look through and see if there's anything that we need to, factor. Well, I think the first one, right? So we have, and what I'm going to do is I'm going to factor down here, leave some space. So because of that minus 12, they're different signs. X squared is x and x, and my factors of 12 are 1 and 12, 2 and 6, 3 and 4. I want a difference of 1, that's 3 and 4. My 1 is negative, so that 4 must be negative. So now when I rewrite this, I'm going to write it down here. My first numerator is x plus 3 times x minus 4. Now, the 8x squared is nothing that can be factored. Right? There's no plus or minus signs, it's not factorable. The next one, 8x cubed minus 2x squared. Well, I see 8 and 2, and I think of they have a common factor of 2. And I see x cubed and x squared. Pull out the smaller exponent, x squared. What does that leave you with? Well, divide. 8 divided by 2 is 4, and this x squared takes 2 away from that x cubed to make it an x. Minus, when you pull the entire thing away, 2x squared all came outside. There's a 1 right there. So there's my new second numerator, 2x squared times 4x minus 1. All over, now let's look at that denominator, x cubed plus 3x squared. No common number, but x cubed, x squared, pull out the smaller exponent, x squared. That leaves you with an x plus 3. There's my new denominator. And then the 1 cannot change, and the 4x minus 1 is not factorable. So there are the numerators and denominators factored. And now let's see what happens. Let's go top and bottom first. Nothing cancels in the first fraction. In the second one, this x squared is going to go away with that x squared. Okay? Remember that this top x squared is not linked to the 2. So the 2 is separate. The parentheses don't change. The last fraction does not change. Okay, now let's look diagonally. X plus 3 here, x plus 3 there. So this entire denominator is gone now. X minus 4 here cannot cancel. 8 and 2. Divide each of them by a 2. We get a 1 where that 2 was, and 8 divided by 2 is 4. This x squared cannot cancel. 4x minus 1, 4x minus 1. So this whole middle fraction is now gone. Doesn't mean anything. This last fraction is now 1 over 1. It's gone. So the only thing that really matters is this first fraction. X minus 4 over 4x squared. And there's the final answer. So remember, we don't divide by fractions, we multiply by the reciprocal. The first fraction stays the same. Every other fraction after division sign, you flip upside down. Okay, so here's our next problem. We're going to add or subtract these fractions. And the first thing we need to do is find our LCD. Now, in order to get our LCD, we have to factor the denominators. So this x squared plus 6x plus 9, let's see if it factors. And I'm actually going to bring this stuff lower. Okay, so let's see. The x squared plus 6x plus 9. Two sets of parentheses. Same signs with that plus c, so then we look to the middle. That's plus and plus. X squared is x and x, and now I want my factors of 9. 1 and 9, 3 and 3. 3 and 3 give me that 6. X plus 3, x plus 3. So this denominator is now x plus 3 times x plus 3. Now I'll do the same thing for the x squared minus 9. Whenever I see a minus sign and I see a squared, I'm thinking it can factor. Well, remember that 9 is a perfect square. This is a difference of perfect squares. X plus 3, x minus 3. So now I'm gonna redo the LCD in color. So now the LCD is the first fraction, denominator, x plus 3, x plus 3, and then anything that's new in the next denominator. Well, x plus 3 is old, but x minus 3 is new. Here is your LCD. So the question is, what does each of your fractions need to make that LCD its denominator? Well, the first fraction is missing the x minus 3. That is what you're going to multiply top and bottom by. Now notice what I do with the x plus 1 on top. I put in a parenthesis so I do not forget to FOIL that out. Now the second denominator is missing that second x plus 3. So I have to multiply by it. Top and bottom. Okay, so let's see. I'm just going to write it like this. So we have the top numerator, the first numerator, x plus 1 times x minus 3, minus, so this minus symbol is that minus symbol, 1 times x plus 3. That's going to be all over my LCD. Remember, write LCD. I would not write out your what it is, because you might start canceling things incorrectly. So what happens here? Well, we FOIL. Now, I would suggest you do the FOIL up top. The first is x squared. The last is negative 3, 1 times negative 3. And then the inner and outer, you get negative 3x and positive 1x. Well, negative 3x and positive 1x is going to give you negative 2x. Okay? Again, if you need to write it out, it's negative 3x plus positive 1x. There's how you get your negative 2x. That's an x, yeah. Okay? Now with this one, we need to distribute the negative sign. It's just a negative 1, so it's not going to change the values, but the signs change. Negative x, negative 3. Now I can still simplify this, so that's all over my LCD. So let's combine like terms. X squared minus 2x and minus x is minus 3x, and minus 3 and minus 3 is minus 6. Now I got to sit and think a second. Can this factor? Well, if I look at my factors of 6, those are 1 and 6 and 2 and 3. Am I able to get a 3 in the middle there? Not even by adding or subtracting. No. So that's not factorable at the top. So this is my final answer. Now notice what I'll do with the x plus 3's for my LCD. There are 2 of them, so I'll put x plus 3 squared. You do not have to, but I think that is the best way to write it, because it's more simple. There's not 3 things, there's only 2. And there would be your final answer. Okay? So when you add or subtract, remember, LCD first, and get your LCD by factoring. Factoring, factoring, factoring. Okay, so this next one is one of those complex fraction ones. We have to simplify the complex fraction. So notice a complex fraction is when you have fractions within fractions, or fractions containing fractions. So we have the numerator is a fraction itself, 2 over x minus 1. And the bottom of this big fraction is a sum of 2 fractions, 4 over x minus 1 plus 1 over x. Well, let's see what we can do to simplify this. Well, the first thing we should do is check to make sure our denominators are factored. X minus 1 is factored, x minus factored, x is factored. It's all factored. So now you have to find the LCD. The LCD is what you're going to use to get rid of all these fractions. Well, I look at the top, and that's x minus 1. I look at the bottom denominator, x minus 1 is already there, and this x is new. So my LCD is going to be x times x minus 1. I'm going to take the top and multiply by x times x minus 1. I'm going to take the bottom and multiply by x times x minus 1. And because this bottom has 2 fractions, you are going to multiply both fractions by this LCD. Now what is going to happen? Your denominators will cancel. This will cancel with that x minus 1. And this 2 gets multiplied by the x only. Now, that's the top. Takes care of the top. Now on the bottom, this x times x minus 1 has to go to both fractions. So let's see. If we look at the first fraction, this 4 is going to be multiplied by only the x, because the x minus 1's cancel. plus, we have this numerator of 1, and now this 1 is going to be multiplied by the x minus 1 only because the x's cancel. So now we simplify. Well, the top is just 2x. The bottom, we get 4x. Distribute the positive 1, which is just going to leave the parenthesis the same, plus x minus 1. So we get 2x over, this is going to be 5x minus 1. Do not cancel out these x's because this is a 5x minus 1. It's all together. This is your final answer. So remember, when you're simplifying a complex fraction, find that LCD. First, factor the denominators, find that LCD, and then multiply top and bottom by the LCD. Things should cancel. No more fractions. Life is easy. Okay, so we'll finish up with 2 solve problems. So the first one is 3 over x squared plus 4x equals 1 over x plus 4. And when you have a fraction set equal to a fraction, this is a proportion. And to solve a proportion, we are going to cross multiply. Okay? Now, it does not matter which you put where. All right? So let's go ahead and put the x squared plus 4x on the left side. So it's going to be 1 times x squared plus 4x equals 3 times x plus 4. And remember, it's a good idea to either put these in parentheses here or write it out like I did, because you don't want to forget to distribute or FOIL or anything like that. So we get x squared plus 4x, that's that 1 that doesn't change anything, equals 3x plus 12. And now at this point, when you have x's and x squareds, you need to move everything to one side. So let's move everything to the side with the x squared. So let's subtract 3x, and let's subtract 12. So this left side becomes x squared. The 4 minus 3 is positive 1x, and the minus 12 stays. This side becomes 0. And now we need to factor. Well, 2 sets of parentheses. My signs are different because of the minus c, so we got plus and minus. X and x are our front terms, and now we need to find the factors of 12. So we look at the factors of 12, and we see that we have 1 and 12, 2 and 6, 3 and 4. We need a difference of 1. That's 3 and 4. It's a positive 1, so the 4 is positive and the 3 is negative. Now this is set equal to 0, so set each one equal to 0 and solve. That's bad 0, sorry. So we'll subtract 4 and get x equals negative 4. We'll add 3 and get x is 3. And here are 2 supposed answers. But remember, you have to look at your original denominators and ask yourselves, can those be my x values? Now, you could do 2 things. Number 1, you could look at them and figure out what x values they can't be, or you could just plug them in. Now, if we take a look at this first denominator, x squared plus 4x, you would first need to factor this to see what the x's can be. So I see a common factor of x, and it leaves you with x plus 4. So in this first denominator, so this is the yellow one we're pulling out here, x could not be 0 because of this, and x could not be negative 4 because of that. When I look at my answer, negative 4, oh shoot, I got to cross that one off. Now in the second denominator, x cannot be negative 4. I already took care of that, so this x equals 3 is a good answer. So that is the one and only answer for this problem. Okay, so here's our very last problem of the year, very last YouTube problem. This says 2x plus 1 over x minus 4 equals 16 over x squared minus 16 plus 3. And this problem is different than the last one because it's not a proportion. It's not one fraction equal to another. It's one fraction equal to a sum of fractions. So we must use an LCD in this problem. So the first thing we have to do is we have to look to factor. Well, this x minus 4 is factored. Now what about this x squared minus 16? Well, I think that's x squared minus 4 squared. And x squared minus 4 squared is a difference of perfect squares. X minus 4, x plus 4. That's that new denominator. And that last fraction, or the last number 3, can be just written over 1. So we look at all of our denominators and get our LCD. Well, the first one is x minus 4. Notice I'll put it in a parenthesis, x minus 4. Now we looked at the second one. The x minus 4 is not new, but the x plus 4 is new. And then the 1 doesn't count. So here is our LCD. And remember, in these problems, we're going to take our LCD and we're going to multiply it through to everything. Okay, so when we do this, things should cancel. Well, let's see. In the first fraction, the 2x plus 1 stays on top. But then the x minus 4's cancel, and we get x plus 4 being multiplied with that 2x plus 4. Then, the 16, the whole denominator cancels out, the x minus 4 and x plus 4, so it's just a 16, okay? And then the plus 3, nothing cancels, so it's going to be x minus 4x plus 4. So that's what happens after all the cancellations. Now what I would suggest is doing this right here. What is x minus 4x plus 4? Well, if you look at the problem, that's right there. X minus 4x plus 4 is x squared minus 16. Change that. So now we need to distribute that 3 to the x squared minus 16. Okay? So again, it's just to try to save you some time. Well, over here we'll FOIL. 2x squared plus 8x plus x plus 4. 2x squared plus 8x plus x plus 4. That's your basic FOIL. Equals 16. And now over here, we have a 3 being distributed to the x squared, so plus 3x squared, and a 3 being distributed to the negative 16, that's minus 48. So I will try to simplify some things. 2x squared, I can simplify the x's, plus 9x plus 4 equals, over here, we get 3x squared, and let's simplify the 16 and the minus 48 and get negative 32. So now I would like to keep x squared positive. If there's 2 here and 3 there, let's move everything to the right side. I know it's a hassle, but we want to keep x squared positive. Subtract 2x squared, subtract 2x squared, subtract 9x, subtract 9x, subtract 4, subtract 4. So over here, we get 0. And on the right side, 3 minus 2 is 1x squared. Nice, no 8, I like that. Then put your x next, minus 9x, and then negative 32 and negative 4 is negative 36. Okay, so now we look at this problem, we need to factor it. My signs will be different, so one's plus and one's minus. To get x squared, I need x and x. And I need to look at the factors of 36. Now there's a lot of them. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now I want to get this 9 in the middle, and I want to subtract to get it. Well, that's 3 and 12. The 9 is negative, so I'm going to make the 12, the bigger number, negative, and the 3 positive. And now I set each equal to 0 and solve. So we subtract 3 and get negative 3 here. We add 12 and get 12 there. So here are our two supposed answers, negative 3 and 12. Now I will look at the original problem and ask myself, are these allowed? Well, if I go to the top, this denominator was x minus 4, so x cannot equal 4. This one was x minus 4x plus 4. Again, x cannot equal 4 or negative 4. And this one had no denominator, so it's good. So the question was 4 or negative 4 one of our answers? Nope. So they're both good. Okay. So thanks for watching. I hope this helped, and we'll see you tomorrow for your quiz.